Hello everyone. In this video, I'm going to show you something very interesting on how to design the LT busbar panel using SOLIDWORKS Electrical. Let us understand this by opening this project from the projects manager with inserting various components, the SLD components, including the meters, the circuit breakers, the disconnecting switches, the power contactors, and supporting devices. If I wanted to add any component, I can easily quickly search on the my macros button or the symbols button, wherein I can type the type of an item. Like for example here, it's a CT, which is a current transformer, which I'm going to add in the power line. So once it has been added, the wires will automatically get terminate, and I have my line diagram has been added. Now I'm going to connect this particular with a cable, which is part of my line diagram tab. So once I have this component, I'm currently searching for a bimetallic relay to be added in this project. So I will search in the symbols library. I'm going to add it here. Once I drop that particular symbol, I will have the manufacturing part can be inserted. Once the manufacturing part has been given for the component, my symbol definition is pretty much done. Now I have my single line diagram ready. Now I'll go to the multi-line schematic, which is a detailed schematic, wherein you can see that the feeder information has been fit in with the ACB which is running in, and then you can see the contacts on the right hand side of this. This is a 3-pole 30 amps no ACB, the 300 amps ACB, which has been part of my LT transformer panel. Right, and then I can, if I wanted to create any new panel, I can go to the symbol properties, assign a manufacturing part, and then go to the parts and change any circuits and elements can also be done. If you are modifying any part, you can modify. Here it is, and then you can add it to the library part also. So once I have done the detailed representation in the schematic for the power drawing, I can go and then check on the other power drawings where the bus bars is part of this. So you can clearly see that there are 3 bus bars, there are 3 feeder circuits, and there is a transformer which is actually feeding the power. The output of the transformer is being fed into a 80 amps circuit breaker, incomer circuit breaker, with a 3-phase bus bars. Now once I add the bus bars, you can see that I have defined the LT subsection 2 with incoming feeder, or there are 4 feeders for the MCC feeders, right? MCC feeder 2, 3, 4 and 5. So wherein this motor control center feeders will be feeding a specific power to a different different components on the load conditions. So once I choose that, I'm going to add few end terminations to that. I'm going to select a few of these buttons and switches. When I choose that, and I wanted to add this in the control drawing, the switches. Once the switch has been added, now you can see that the switch are automatically taken. Next is subsequent component naming. Now I'm going to insert one more component from the symbol insertion. As I said earlier, I can add this component by duplicating this. To avoid the duplication, we just copy and then paste it. It will take the next subsequent number, or you can go to the insert symbol a wizard and add these things. So once I have the components, we know the normal procedure to give the manufacturing parts manager. So once I give the manufacturing parts manager, now you have the symbols, manufacturing parts also associated with it. Now the symbol has been fully defined. It is constrained and it is been fully defined. At any time, if you wanted to minimize the attributes, you can still do that. Now my schematics and the single line diagram has almost been freezed. Now I'll go to the subsequent drawings. I can generate it to the 3D and see that how the SOLIDWORKS assembly can be generated from the 2D electrical creation of these sub-assemblies based on the location of the components and the wiring, right? So once I have all this information, I can very well go to the mechanical 3D, and I have this subsection 2, LT subsection 2, where it will have all the wires running, the other subsections of these MCC panel having the bus bars running inside. So wherever I need to run the wires on the doors inside that particular cabinet, you can see the it's a compartment wise, a stacked compartment. It's a stack compartment, right? And I have few components already been positioned in 3D using electrical 3D application running on mechanical 3D. So once I have all this information, I can easily insert the components which I have placed it in the electrical 2D, right? So I have basically opened the same project with the help of electrical 3D, wherein I can very well manage the project management, open the same thing. So by this way, the electrical and mechanical engineer is basically accessing the same data and same project, and they can execute their own tasks independently for the same project. Now I'm going to insert few components which are relevant for this particular project in 3D. So once I have these components inside my LV project files, I will locate them in that particular project. I'll choose that component. Once I select that component, which is MCCB for MCC panel, and I can drag and drop onto this rail mounted MCB, which is an incomer MCB for my design. So once I have my components positioned, so I can also try and insert one more component or associate one more component, which is a single pole MCB, which has been designated by Q17 by the electrical engineer. Now the component insertion has over. We'll see that how the components have been related to the project tree. So when I highlight something on the project tree, it is going to show me on the 3D space that the equivalent 3D part associated with it. So this way, the schematic which has been designed by the electrical engineer in 2D can be integrated with the mechanical 3D using SolidWorks Electrical 3D application running on top of SolidWorks Mechanical 3D. Once I have all the components ready, I have chosen route wires inside the control cabinet. I have given the parameters like 50 and then 400 for the routing parameters. Once I say that, I choose a respective SolidWorks route for this, and I'll say OK on this. Once I choose that particular algorithm, I'll say OK on this. The moment I press this button, OK, then it starts the routing. The algorithm which I've chosen, which will go to the 2D electrical schematic, logically verify the details of it, and then come back to the 3D, relate the parts, and analyze and route it automatically. It will also throw the analysis window wherein any problems arises. Now you can clearly see that the wires have been routed with their respective paths connected to different elements based on the logic defined in electrical 2D. Right? So you can see that for ease of convenience of visibility, I'll put this in a transparent mode. You can see the wires which are actually taking typical bend radiuses, connecting to different components on the doors. Right? Now my wiring for this cabinet has been done. I'm saving this particular file. I'm going back to the master assembly where I can see the stack compartment with the bus bars. Along with that, I will also see this particular stack compartment which is been wired now for the purpose of the control wiring, which is part of my LT transformer panel in the master assembly. Let me put it into the front view. Now you can see that this is being actually controlled to the transformer. It's an oil-cooled bigger transformer, and you can see the wired panel which is stood in the right hand side of this. Rest all others are the bus bar panels. Now I'm going to show you something very interesting wherein inside these bus bar panels we'll see that few of them are like single phase being connected, few of them are like a RYB, and then there's a neutral wire which is in a black color has been in. There are like the bus bar chamber at the bottom, which is the bus bar entry, like it's a bus bar duct wherein you can see all the 4 different bus bars equally spaced within insulators, and you will see a few other components in the door and has been added onto the different compartments for the incomer feeders or outgoing feeders. You can see different data reading meters, which is part of this, right? And we'll also see the wide panel control panel, which has been part of this stack compartment. We can easily locate these components when you click on the component on the 3D side, which will be visible in the project tree also in the SolidWorks. And the mechanical and the electrical will follow the same component nomenclature throughout your design. Now, the wiring has been done, the other parts of the bus bar also being done. Now we will see that how can we add few things to route the cables in this particular panel. So I'll go to the route cables. I'll set the origin destination of the cables. For cables, as you know, the cables can be connected between two components, right? Two or three components. So I need to define what are these cables basically, what is the specification of the cable, from where to where it is running. You can see from the transformer to the transformer which is outside, which is kept in outside, and there are three bus bars. Between them there is a cable which is W1. There are three core cable which is running between them. So this is the same cable with the same logic of transformer T4 with the three bus bars, which is part of my mechanical assembly, can be routed now. Let us see how this can be done. Now I'm going to just relate the transformer. You can see the transformer T4, as I said, this is a bigger transformer. I have associated that, and I also associated the bus bars from where the cable can be originated, that can be connected to. So once I have all the associations done for the bus bars, and these associations, remember, J15, 16, 17 are the same bus bars which I have used, the same nomenclature has been used in the electrical 2D. I'll set the origin destination for this cable W1 inside the select cable. So once I have this cable, the core information which has been mapped, once it has been mapped, you can see that the origin destination for this particular cable has been mapped from the power cabinet, from the feeder, the main feeder, to the transformer. I've set the origin destination. Once the process has been done, now we can select the route cables. Once I select the route cables, I've defined few parameters like using splines and route the select a particular component to be routed, giving the route parameters, right? And choose the right and shortest path algorithm for optimization of the cable which is being running, connecting between the transformer power terminals and the bus bars. So once I have defined all the parameters, I'll say yes. Once I say yes, okay, then the route cables, choosing the route, optimizing the cable path can be arrived, and route cables can be achieved within 30 minutes. We will see that cables can be formed and that can be added onto it. Now you can see whichever the component is being routed is being graded out, and the cable will be connected in very short time into this. Right now the cable has been connected here. You can clearly see the cable has been connected here. Once the cable has been connected, the routing analysis window will populate, and it will tell us that the route parameters have been validated and the routing happens between these three bus bars connected using that path, going back, connected to the other part of the cable. Right, so this way we can very well design the circuit and schematic using SOLIDWORKS Electrical 2D and route your wires and cables in electrical 3D for the LT, LV, medium voltage and MCC kind of a control equipment. Thank you for watching this video. Thank you.